Hello friends, welcome you all. In this video we are going to study some part of the polarization of light. Already we have studied polarization of light in detail. Now in this video we will study some part of this polarization of light. Before that we study some terms which are related with the polarization of light. That is, what is a plane polarized light? When light travels along a certain direction, the vibrations take place in a direction at right angles to the direction of propagation. If the vibrations of the ether particles are linear and take place parallel to plane through the axis of the beam or the direction of propagation, light is said to be plane polarized. Now, what is the elliptical polarized light? Remember, when the vibrations of ether particles are elliptical, having a constant period and takes place in a plane which is perpendicular to the direction of propagation of light, it's said to be elliptically polarized light. In this case, amplitude of the vibration changes in magnitude as well as in direction. And the third one, circularly polarized light. When the vibrations of the ether particles are circular, having constant period and take place in the transverse plane, light is said to be circularly polarized. Remember, in this case the amplitude of vibrations remains constant but the direction changes only. Now, what are the waveplates? Waveplates are nothing but transparent plates with a defined amount of birefringence which are used for modifying the polarization of light. It is also called as retarder plates, or they are also called as the retarders. Now, what are the retarders or waveplates? A waveplate or retarder is an optical device that alters the polarization state of a light wave traveling through it. Two common types of waveplates are there. The half waveplate, which shifts the polarization direction of linearly polarized light, and the quarter waveplate, which converts linearly polarized light into circularly polarized light, and vice versa. It is played from doubly refracting uniaxial crystal with its optic axis parallel to the refracting faces. It can introduce a given phase difference between O and E rays which travel through it. The phase difference delta is equal to 2 pi by lambda into d in bracket mu naught minus mu e. A quarter waveplate can be used to produce elliptical polarization as well. So this is all about the retarders. Now if you look at this particular diagram, then you will find that here this is nothing but the linearly polarized light, and here this is also a linearly polarized light. This is a half wave retarder, this is the fast axis, and this one is the slow axis. Now, what is the quarter wave plates? A quarter wave plate is a thin plate of birefringent crystal having the optic axis parallel to its thickness adjusted such that it introduces a quarter wave, that is lambda by 4 path difference or a phase difference of 90 degree between the E ray and O ray propagating through it. If you look at this particular diagram, then you will find that here there is a light which is traveling in this particular direction. Here we have a quarter wave plate. When it falls on this particular quarter wave plate, then we are getting circularly polarization or circular polarization, and here we are getting the linear polarization. So here this particular plate is called as a quarter wave plate. Now, creating circular polarization using a quarter wave plate and a polarizing filter. If you look at this particular diagram, then you will find that here this one is one of the quarter wave plate and this is a linear polarization. So when unpolarized light is falling on this particular linear polarization, then we are getting linearly polarized light. And when this linearly polarized light is allowed to fall on this particular quarter wave plate, then we are getting here circular polarization of light. So this is how do we create the circular polarization, by using the quarter wave plate and a polarization filter. A quarter wave is a thin plate of bifringent crystal having the optic axis which is parallel to its refracting faces and its thickness adjusted such that it introduces a quarter wave, that is lambda by 4. Path difference or phase difference of 90 degree between the E ray and O ray propagating through it. When a plane polarized light wave is incident on a quarter wave plate, the wave splits into E wave and O wave. The two waves travel along the same direction but with the different velocities. As a result, they emerge from the rear face of the crystal with an optical path difference. Now, thus for a quarter wave plate, mu E minus mu naught into T is equal to lambda by 4. Let us consider this is an equation number 1. Now we know that T is equal to T by 4 and therefore we can rewrite this equation as mu D is equal to T by 4 upon mu into mu E minus mu naught as an equation number 2. A quarter wave plate introduces between E ray and O ray a phase difference delta given by delta is equal to 2 pi by lambda into delta is equal to pi by 2 is equal to 90 degree. Now a quarter wave plate is used in producing elliptically or circularly polarized light, which converts the plane polarized light into elliptically or circularly polarized light, depending upon the angle that is incident light vector mixed with the optic axis of the quarter wave plate. Now if you look at this particular diagram, then this is the diagram by which we are getting the circular polarized light with the help of circular polarizer. Here we are having linear polarizer. When it is allowed to fall in this particular plate, then we are getting the circularly polarized light. Here we are having the compact disc detection by which we can detect it. Now what is half wave plate? If you look at this particular diagram, then again you will find that there is one plate where this particular light is falling. Okay, so this particular light or that particular wave is getting rotated at 45 degree. So ultimately here we are getting the circular polarized beam. So a half wave plate is a thin plate of bifringent crystal having the optic axis to its refracting faces. This is the optic axis to its refracting faces and its thickness chosen such that it introduces a half wave, that is lambda by 2 path difference or a phase difference between E ray and O ray. When a plane polarized light wave is incident on this particular half wave plate, it splits into two waves, that is O waves and E waves. So the two waves travel along the same direction inside the crystal but with the different velocities, and as a result, when they emerge from the rear face of the crystal, an optical path difference will be developed between them. So here we can write mu E minus mu naught into D is equal to lambda by 2 and D is equal to D by 2 into mu E minus mu naught as an equation number 2. So a quarter wave plate introduces between E ray and O ray a phase difference delta that is given by delta is equal to 2 pi by lambda into delta is equal to, that is nothing but a 180 degree. So this is nothing but half wave plate. Now a wave passing through a half wave plate is like this only. This is how the wave passes through a half wave plate. Now difference between half wave plate and quarter wave plate. This is the half wave plate and this is nothing but a quarter wave plate. So here if you look at this particular half wave plate, we are getting the different polarization, and if you look at this particular quarter wave plate, we are again getting some different polarized light, that is elliptically polarized light. So this is the main difference between half wave plate and that of quarter wave plate. Now elliptically polarized light, if you look at this particular diagram, then this is nothing but the unpolarized light which is allowed to fall on this particular nickel prism and after falling on it we are getting the plane polarized light. And again, if this plane polarized light is allowed to fall on this particular that is wave plate, that is quarter wave plate, where theta is not equal to 45. So here we are getting the elliptical polarized light. So unpolarized light is allowed to fall on Nicol prism. Then Nicol prism gives you the plane polarized light, and then it is allowed to fall on this particular quarter wave plate, that is vibration in the incident light, making an angle that is theta is not equal to 0, 45, 90 degree with the optic axis of quarter wave plate, and hence we will get the elliptically polarized light. So this is what we call it as an elliptical polarized light. Now let us talk about production of circularly polarized light. A quarter wave plate and a polarizer are the optical devices necessary to produce elliptically polarized light. Two Nicos are at cross position. If quarter plate is at 45 degree, light passing through it will be circularly polarized. So no variation of intensity with the rotation of Nicol. If the angle of Q wave makes other than 45 degree, then emergent light is elliptical. And if you look at this diagram, so you will find that this particular Nicol works as a polarizing Nicol, and this is nothing but the quarter wave plate, and this is nothing but the analyzing Nicol. So here, this is how do we produce the circularly polarized light. Circularly polarized light, as I already told you, when this unpolarized light is allowed to fall on this particular Nicol prism, then we are getting the plane polarized light. And when it is allowed to fall on this particular quarter wave plate, ultimately we will get the circularly polarized light. So unpolarized light will be falling on Nicol prism, and then we are getting the plane polarized light, and plane polarized light falls normally on the quarter wave plate, such that the vibration in the incident light making an angle 45 with the optic axis of quarter wave plate, and hence we will get the circularly polarized light. So this is how we are getting the circular polarized light. Now let us study some numericals. There is the first numerical where we have to calculate the thickness of quarter wave plate for light wavelength 5893 angstrom, given refractive indices of ordinary and extraordinary, that is 1.544 and 1.553. So if you put the value, that is mu naught is equal to 1.5 and mu is equal to 1.5 and lambda is equal to 5893. In this particular equation, that is d is equal to lambda by 4. So we will be able to find out the d, and that d is nothing but 0.1637 into 10 raised to minus 4 meter. So this is all about this particular polarization of light. So thank you so much.